If you are building LLM applications, RAG pipelines, support agents, or internal copilots, you have probably spent hours for hand tuning prompts. And what we do in this kind of approach is basically you test a change, eyeball the output, tweak again, and repeat. It works, but it doesn't scale, and you have zero traceability on why one version was better than another. But what if your prompts could optimize themselves the same way we optimize hyperparameters in classical ML, but all using natural language reflection? And that's exactly what this project does. I built gepa-langchain-lab, which is an open source project and a boilerplate that wires together three things. One is LangChain for the RAG pipeline. Second is MLflow, basically for observability and tracing. And then third is gepa for optimization of the prompts. I also have Mega over here for optimization of workflows, but as of now, this is optional and we will focus more on gepa. The result is a closed loop system where you build, measure, and optimize. And the optimize step is handled by AI that reads its own failures, traces, and those kind of things. Let me walk you through how this works. Here is the project which I have just cloned uh, from this repository, and I have created a Python virtual environment and installed all the dependencies over here, all the requirements, libraries, and everything. Now, over here in the code, if you see, uh, there are a couple of things which are happening in terms of like maybe I have created a demo folder which will be taking the benchmark. Then over here there is a eval, there is a ingest, optimize, etc. But first, let us have a look what is GEPA. And GEPA, like the abbreviation GEPA, that stands for genetic Pareto. It was introduced at ICLR 2026, and this is basically fundamentally a different approach to prompt optimization. If we look into traditional RL based methods like GRPO, they need thousands of rollouts to learn. They kind of collapse everything into a scalar reward and signals, and GEPA takes a different path as compared to that. It uses LLMs to read the full execution traces, which we will be collecting in MLflow in our project, and the reasoning, the tool calls, the errors, and everything. And basically, it diagnoses where a candidate prompt failed, proposes some target fixes, and using that, maybe evolutionary selection with Pareto awareness to keep the best variants. That's the main logic. The numbers are compelling. Like I remember GEPA outperforms GRPO by like maybe around 19-20%. I don't remember it exactly. But it is not just academic or like published in papers, some workflow and those kind of things, some tooling and all. It is integrated in MLflow's optimize underscore prompts function, and also Google's ADK, Pydantic AI, those kind of things. And one interesting part is when Shopify's CEO called it severely underhyped, because it is true. This is basically for production grade systems. And if we look into the architecture, here is our rack pipeline. This will ingest everything, all the traces into MLflow, and then finally the optimizers will work. The good part is that over here, you will not be optimizing it once. You will be creating a continuous improvement cycle as a loop, and then it will keep on going. Let me show you the project structure now. Over here, build, measure, optimize, those were the three layers. So if we look into our prompts file, which is this one, right? It defines four strategies: base, strict, detailed, and conversational. Now, these are basically like these, each of these are basically representing different trade-off. So base, more balanced. The strict one is more kind of restricting beyond the context. The detailed one is quite comprehensive, multi-section answers. Conversational is language and analogy oriented, and so on. Now, these aren't just templates, they are the search space for GEPA. And The optimizer will test variants derived from these and evolve towards the one that scores the best in your evaluation set. And now here, if we see the ingest.py, so as of now we have taken the sample data, but we can point it to any vector database like maybe FIAS, Pinecone, VV8, those kind of things, and it will be a one-line change. The reason is that uh, the the keyword matching here, which is basically the simple retriever, uh, this extends LangChain's base retriever, right? And for the boilerplate, this was fine, zero dependency, no vector DB required and all. That's why I have kept it. And everybody uses something different, right? So I did not want to do that intentionally, but it can be switched. And then we have app.py file. Now here, this is the rack chain. And obviously, one important thing to notice over here will be the MLflow uh, auto logging that is enabled, right? Then we have the eval.py. Here it is like this is the whole evaluation harness, and it takes an eval set, a list of questions and expected answers, like a pair of that, and runs each through answer function. That is the main part over here for this particular eval file. And now the thing, if you go into like the main part, which is the optimized part, now this is the gepa portion. Here, interesting part, the optimized.py file. This implements a simplified gepa loop. It generates prompt variants from the base, uh, evaluate each of these variants, right, against like from the base, like evaluates these against the training data, like with the keyword matching accuracy and so on, and basically selects the winner. And in a production system, you would maybe want to wire this with a full gepa package, uh, maybe for reflective mutation and Pareto frontier tracking. But the structure is identical. That's the main portion. And then I have something for Mega as well, which I mentioned is an optional part. And this is basically the main part is a workflow optimizer. So kind of uh, going through different routing rules and those kind of things and generating variants out of it. Let us maybe go to the live demo, and for that purpose, we will need to start the MLflow UI. And here, this is done, which is good. So here I can bring in, I can kind of maybe first start let me do that MLflow UI. We will be hosting it on local and port, which generally goes the default as this one. We will give that now. Now, the steps of the demo will be kind of three steps. And one thing I wanted to mention that here there is an env file. So I have created a copy of this example env file and then pasted my Grok API key in that particular original env file. So here for this particular demo purpose, we will be using Grok. However, if you go to the README file of the project, this actually showcases how we can change some of the other providers as well. So if you want to do that, you simply go through this and then all the things are actually written over here. You will be able to do that. But we will focus mainly on our part, which is basically running it, testing it. Now, this is starting up. It may take maybe a few seconds. Meanwhile, I will go to the browser and then try to open up the URL over here, which is on 5000 port. Okay, so this may take a while. I think it is coming up. Server has started. Okay, perfect. So it should come up now, which is this one. Let me make a little bit small. So here, if you see this one is default, but it is not like our part at this point of time. Now, what we will do, we will go back to the terminal. We will let this like be running. Here, I have a different window. Let's clear this up. And here what we are going to do is first we will run the benchmark. So again, the Python file that we have already seen, it was under demo. we will run this, and let me go back to showcase this file. This is the one. So this will be kind of a scoring. Now here, this is default question answer, uh, the scoring of those uh, question answer based on the expected answer. So that will be done. And if you see here, the benchmark is now being triggered. It is showing percentages. Let it complete. And then it will also show us the final average percentage as well. Okay, now if we go up, so here the benchmark tool has run 8 comprehensive test cases, as we have seen in that question answer. It is giving expected what it is getting, and then based on that, some percentage whether it is good or not good. So for example, if we come down here, it is showing 47% score, match score, and needs improvement. So this is where GEPA will come into picture. In the next run, then we can see uh, all these needs improvement as well. And the match score is almost 63%, and questions above 70% are 3 out of 8, like less than 50%. And what is the interpretation? So it is giving that kind of uh, information as well, right? And all the categories that we have seen earlier, right? All the variants, so that is also present over there. Now this is done, so we will reduce this. Okay, what is the next step? So the next step will be to first see whether we got any benchmarks or not, traces or not. So here, if you see, yes, we have got it. Let me squeeze this a little bit. Right, so we have got some traces, 16 requests, and then we have some information around that, right? So good. So that was our main intent. Okay, the next step will be to run the optimize script, which is under the source directory. Optimize. Now, what it does, this will call the GEPA construct, and then it will be kind of doing all those optimizations. So this may take maybe about a minute or so, maybe 1 or 2 minutes. This will create all the variants, optimize it, and the main intent is that next time when we run, right, then it should be doing something better, right? And it will go against each base, strict, and those kind of variants. And we will skip mega for this particular demo. However, the next step after executing GEPA optimization is to execute mega optimization. For now, because we don't have much of a complicated workflow, right? We will be skipping that part, and we will directly maybe go to the kind of rerun and comparison. One more thing that here, if you see some of the dependencies which are mentioned, which are required, are these ones. We are going with GEPA 0.1.1. That is the main version, and some other, obviously, LangChain stuff is there, the MLflow version and all. So that is another part. All three it has done, only fourth one is remaining now. Okay. And one of the reason like why we have gone for this this particular boilerplate, these particular tools, right? So LangChain, mainly for orchestration, it's the de facto standard for composable LLM chains. And good part is that it has native MLflow integration. Grok I was using, which is mentioned over here, Grok I was using because it's free for sure, and fast, quite kind of efficient, and it has a very seamless LangChain integration as well. So that was the reason. MLflow for observability, traces, experiment tracking, and all. Uh, and from here, the Kepa will read that. I was also thinking of Langsmith, but Langsmith is a SaaS offering, so I thought to use MLflow for now. And Kepa I already mentioned, so these were the main reasons. Now I will go back. I think by this time it would have been done. Yes. So all these variants, it has run, optimization has been completed, right? And this what it has done behind the scenes, it has kind of gone through all the previous baseline information, and then it has tried to understand it better as compared with the previous one, which is like here. So based on the traces previous run and then the traces, so what wherever it got confused, any hallucination, maybe any rate limiting issues, any errors, etc., so it will take care of all that thing and then optimize that. That's the main idea. And now let it complete. I think still some part is pending, and we can meanwhile go to the MLflow UI, right? Yes, so here we have the traces, we have got some more information. As you can see, 80 requests, right? Good. So we have some things coming up, which is the intended part. Okay, this is complete. Now there are two options. One is that we can run the source app, and then give our like uh, input as a user in the terminal. That is one part. Or basically we can rerun the optimization part of it, like maybe the benchmark tool we have run. In a similar way, we can run the eval part of it now, and then we can see how's the performance now. So let us try rerunning the benchmarks once again. I will go back. Yeah, so basically, sorry, I need to go here. Yeah, this is the one. So let me run the benchmark once more. Okay. Has it completed? Let us quickly check that. Yeah. Hmm. Now you can see the in the summary it has increased. So earlier it was like three only out of eight, which were giving the intended or like more than 70% performance, but now there are five. So that's the main funda over here. And let us to quickly try to validate that part. So when the benchmark ran for the first time over here, then it was 3 out of 8. Average score was 63. Questions with more than 70% were 3 out of 8. But now, when we have kind of optimized it, and then when we have ran it once again, now it is 5 out of 8. So, like two more questions got into the category of more than 70%, and from 63, this has also increased to 69. This was a very quick demo to kind of showcase how uh, like we can optimize a very simple repository of kind of a simple kind of prompts rack chain, right? And then like make it more effective. Now imagine that this is a production system, not kind of a boilerplate or a demo, right? So if that is the scene, that it's quite a huge win, and if we include mega on top of it, then it will become more effective, right? So that's the main funda. And here, if you see this particular boilerplate over here is for anyone building RAG applications who wants to move beyond like manual or maybe guess and then check prompt engineering. And if you are building support agents, internal knowledge assistants, and so on, this is quite helpful. You can fork this particular repository on this URL. I will be pasting that as well. And then you can kind of swap the LLM providers and other stuff, as I mentioned, on your own, as per your own preference. Please start the repo if this is useful. Open issues if you have any questions, and fork it to build on top of it. We'll be putting up the link in the description. My name is Saurabh, and I build open source AI infrastructure for enterprise use cases. And I try to mainly find out the white spaces or the gaps where people are not focusing much. Connect with me on LinkedIn. I am also quite active from some time on X, Reddit, and Discord as well. So feel free to connect and exchange notes. Thank you.